So in GenAI's terms, raw data is actually more valuable to us than very normalized, very standardized data. I don't think people have really done much of the computational demands yet. I don't think they've gotten into what this looks like at scale. I think that's probably the strongest thing that we're seeing is the integration points are much easier for us because of GenAI's ability to understand data, translate data into different formats. Andy Fanning. I am part of the technology and operations organization with Cigna. My title is the VP of Business Transformation. So looking at how do we bring advanced technology into the business world to make sure that we affect how things get done. The way we're seeing GenAI affect patient care at this point is largely around administrative tasks for physicians. So things like taking the notes for the doctors. So being able to understand a conversation, being able to transcribe that conversation and take all of the post-visit summary notes, recording all the relevant codes, the ICD-10 codes, and all the pharmaceutical information for that visit. So the doctor doesn't have to spend so much time on administrative tasks, which is the #1 cause of burnout for physicians in the industry right now. And so I think that's the biggest real world impact that we're seeing GenAI as of today. One way institutions and stakeholders are adopting GenAI is to look at their landscape and try to figure out, there's 3 different horizons that they're looking at. One is make what they already do better, faster, and cheaper. So essentially take all the administrative tasks and then figure out where GenAI applies, and then be able to apply GenAI to those administrative tasks to make it cheaper and better for the stakeholders. The second is really around expanding business models. So take your existing business models and add new features, add new services, so that you make a better value proposition for your existing clients. And then the last is really around wholly new business models that we haven't seen yet. And so those 3 horizons are what I see most of our industry looking at GenAI to help with. So compatibility with GenAI is actually one of its strongest points. It's able to understand data in any format, right? So unstructured data is now readily available for us to use as part of our infrastructure and be able to integrate into existing applications. And so I think that's probably the strongest thing that we're seeing is the integration points are much easier for us because of GenAI's ability to understand data, translate data into different formats. And so you can have it make you a JSON that you load into some system, or an XML document, or an X12 document, right? So it's able to do that translation on the fly and able to understand raw data much better than we've ever been able to do in the past. So some of the challenges that we're seeing is being able to work with and store raw data, right? So in GenAI's terms, raw data is actually more valuable to us than very normalized, very standardized data. And so one example of that is as you're looking at a call transcript between a doctor and a patient, if you get the transcript, you're able to understand how that visit went. But if I get the raw audio, I'm actually able to interpret anxiety and depression based on the vocal sounds of that audio from the patient. And so raw data in that scenario actually provides a way more data for us as a healthcare organization than just having the transcript itself. And I think that's the big challenge, where we have set up all of our technology systems to look for very standardized, very normalized data, where birthday falls into month, day, year, everywhere across our systems. And now we're actually wanting the raw. We want the voice, the actual voice file, the actual wave file, the actual high-res mammogram. Like, all of this stuff has much better data in it than just the actual normalized data that we would normally look for. And so I think that's the challenge, where we have to look for how do we get those raw data streams, how do we store that raw data, how do we categorize it and be able to use it long term. I don't think people have really done much of the computational demands yet. I don't think they've gotten into what this looks like at scale, right? So we see a lot of experiments, we see a lot of trial and error and trying to figure it out. I think the computational demands, on one hand, will be big for certain applications. On the other, we have a lot of tools and techniques to make sure that those don't get out of hand. And so I think that it's very early days for GenAI. So a lot of the hyperscalers like Google, Microsoft's of the world are putting these into their infrastructure and figuring out how to use them. And just like any new technology, it's going to be expensive at first. And so the computational demands will come down over time. And then we'll have additions of small language models that are able to do a very specific task that are 100 times cheaper than using a very, very large language model to do that task more generally. And so I think that for now, we're not worried too much about the computational demands, given the scale and given that we know it'll come down, and given that we have different options for how we're going to use GenAI in the future, given the smaller language models, very specific use cases, trained on our data to be able to answer our questions. So I think it goes back to my other answer around raw data. I think it becomes a part of our ecosystem that we have to deal with. The good news is that places like Instagram and Facebook have dealt with large video streams, large WAV files, large raw data streams for a long time. So the tools and techniques are there. The computational demands are higher and the data storage demands are higher. But I think that we already store most of this data anyway, right? So in a large company like ours, we have lots and lots of data storage in lots of places. Really, it's about how do you get that data to GenAI to be able to make decisions on, rather than creating new data, right? So I think there's a difference. GenAI is able to understand a lot of data and give us answers to questions easier, but it's not necessarily creating new amounts of data for us.